Alrighty. Um, Hello everyone. So, I think we'll give it about, say, a minute for a couple more people to flow in, and then we can go ahead and get started. So, 1 minute and then we can get started. Alrighty, so we can get started now. So, hello everyone and welcome back. So, in this lesson, so we are going to start really understanding the code, modifying some of it, and even rewriting parts of it, because writing the code is probably the best way to really understand what is going on inside a program. Obviously, copy and pasting from the web will get you results much faster, but you won't be able to recreate it yourself, I guess. So instead, what we're going to do is we are actually going to take bits of the code and modify it in a way that shows that we really understand what is going on. So I will go ahead and switch to our PyCharm. So PyCharm is the application that is used once again. So we're going to make a new file, and this is going to be called Pong rewrite. So this is rewriting Pong. And in this Pong rewrite, we're not going to have anything copied and pasted into here. It's going to be a completely blank template. And the first thing that we want to do is we want to look at the Pong test structure. So the first step in writing programs, just like how we did it in coding bat, is actually going ahead and writing the pseudocode. The pseudocode being the code that's kind of expressed as regular words rather than actual programming. So oftentimes the pseudocode is a lot easier to understand and easier to write. So we look at this, it's all defining variables here. We need to make sure that we have our colors defined to make it easier on us, a lot of variables, and we get into our first method. We have defining ball init. Well, init is actually short for initiation. So initiation is essentially the starting or making the existence of, I guess, of certain variables. And essentially what ball init does is it initiates some of the needed variables in order to define the location of the ball, the direction the ball's going in, how fast it's going. So what we notice is, alright, so we need to define variables for our ball function, or our ball object, right? That is going to be the very first thing that we want to do. So this is going to have to be a comment so it does not give us an error. And once we do this, we might want to get a little more specific. So we want to define position. So we have defined position down. What else do we need? Well, we can see, all right, well, the current position and velocity are stored there, so we don't really need to bother about that. This is still the position. But we notice that it actually talks about velocity, and velocity, meaning something that has both speed and direction, has to we have to have these variables stored somewhere, and that is right here. So what we want to do is we also want to define velocity. So we have our first method down, and once we've done this, we can go ahead and move on. So our second method, initiation, or init, right? Init is just a generic defining function. It's a function where instead of just, I guess, going ahead and defining him over here at the top of the program, is defined inside of a method, and this is part of the concept of code reuse, as defining it within this method allows you to call this over and over again. And in the case that you might need to call it for, say, 2 different paddles later on when we shorten the code, this writing inside a method will help greatly. So we want to define our other variables. So once we've defined our once we've gotten to the concept of defining our other variables, we actually need to get into the specifics. Well, in specific, we want to define the position of our paddles, including both 1 and 2, right? We can also just write that as 2 paddles, like that. So this is where we can find the defining of the 2 different paddles. It's I guess pretty much out there. It's pretty easy to find ourselves. Next thing is we want our scoreboard, left score and right score, just keeping track of the scores. So scoreboard, right? And finally, we want to look, all right, what in the world is this, right? Well, once we go back here, we can notice something, right? This ball init function actually has a parameter, and we will get back to this, so we will leave this out for now, but this is where ball initiation is called. So essentially, this entire initiation function can, technically speaking, include ball init as well. But the person who wrote the original code obviously wanted to split it up, maybe to make it look a little neater. Obviously, smaller code blocks are easier to read, easier to edit, especially if you have different functions like this. So we're now done with our 2 initiation functions. Our next thing is we want to go ahead and define the drawing of the canvas. And if we notice, if we are to go ahead and run this program, there's a blank canvas at first. So in case some of you guys haven't seen it, or some of you guys need a refresher, we can go ahead and run Pong test here, and we can see there's this entire field setup where the program has to draw everything on here, right? It's not just going to appear without us actually programming it in. So now that we've gotten that through, I guess, so we want to take a closer look at what's exactly inside this draw function. So first off is we notice this is probably the biggest function. This is the biggest function, actually, of the entire program. It takes up pretty large amount of the code here, from line 64 all the way to line 136, so it's a good 80 lines of code. What we notice is, first of all, there's a bunch of drawing lines. So this is going to be part of our draw function, so drawing the board. And the first thing we want to do is draw the outline. Right, this is gonna be like, you know, the line in the middle. It's never gonna move. The lines that kind of indicate the boundaries, just something for our eyes to rest on and I guess identify as the actual boundary. The next thing is actually going ahead and noticing, all right, this is no longer technically part of a drawing function. Rather, this is actually calculating exactly where the paddle should be. If we go ahead and think about how this Pong game works, the paddle can only move in 2 directions, being up and down. There is no left and right. Why is there no left and right? Well, there's one simple reason, because this game wasn't really designed on, I guess, a big platform or anything like that, and just moving the handle up and down was already hard enough, and I guess the game creator just didn't want to make it any more complicated. Moving it up and down makes it easier for us if we're trying to go ahead and start it at first, but that's another example of a variation that we can write in order to make this program slightly more interesting, right? So once we go ahead and we finalize going over this and we can understand, all right, this is all talking about the paddle's vertical position. We notice that there's two huge code blocks here. There's one over here and there's one over here. And if we are to go ahead and just Control F paddle 1, we can notice that everything in here mentions only paddle 1. Whereas we switch this into paddle 2 and this code block suddenly turns into paddle 2. Meaning that there's a bunch of wasted code here. If we were to go ahead, write this function on its own, right? We were just to take all of this out, delete all of this, and go ahead, put in a new function, we could shrink this in half easily, right? This is an example of how we can go ahead and implement code reuse in the next coming weeks. So we want to go ahead, and I don't really like including updating the paddle, so I'm going to write a new function. This is going to be called moving the paddle. Moving the paddle is obviously a part of the program that needs to be written, so it's important that we are able to acknowledge that here. And next thing is updating the ball. Updating the ball I can kind of understand as part of the drawing function, so I'll give it to them here. So I will say update the position of the ball. Finally, we can go ahead and see, all right, what is this here? What this is essentially going ahead and drawing everything out. What happens is every frame, the computer has to redraw and recolor every single pixel that you see. Every single pixel you saw on the board was not something, that was taken from the last frame and then slightly changed. No, instead, what happens is the entire board was redrawn, and instead, the coordinates of the paddles were slightly different, and as a result of that, or the ball, and as a result of that, it made it look like the ball and paddles were moving, when in reality, it's more like they're, I guess, teleporting would be a little bit more accurate, except it's teleporting so fast that our naked eye can't actually detect that, and instead just registers it as a moving ball or a moving paddle. So that's a rough explanation. If you have any question on exactly what I mean by that, feel free to ask. It's a little hard to understand, obviously, if you don't get it. So what we want to do is we want to draw the paddle and ball, right? We can notice that in here, when we go ahead and draw the board, we only drew the outline of the board. So obviously the ball and the paddle still need to be drawn, and that is taken care of here. So finally, we can move on and we can determine, all right, over here it says ball collision. Well, we look a little bit more down and we see another ball collision. All right, well, what's the difference? Ball collision check on top and bottom walls. What this means is that there are 4 boundaries when we go ahead and we run this program. The 4 boundaries being the top, the bottom, the left, and the right. So we can take a look at the behavior here. We notice that if it's going to hit the top, it will simply bounce off. Nothing happens. However, if it goes ahead and enters either the left side or the right side of this board, it will disappear and respawn back in the middle. Why is this? Well, we can look at the scoreboard. It's because on every single one of these, what's happening is it's scoring a point for the opposite team if it enters your side. So we now understand why we have to have 2 different methods, because they have 2 very different behaviors. So once we go back to the code here and we look at this, we notice, all right, First of all, this is not part of the draw function yet again. So we're not going to write the pseudocode inside the draw function. Instead, we're going to change the name of this function. We're going to just call it movement. And if we want to be more specific, we can say movement of paddle and ball. And inside movement, we want to make sure we update paddle location. And we also want to update our ball location. Now, you see, there's actually a duplicate right here. And this duplicate, it shouldn't be here. And this is part of the programming process. We notice something that seems out of place, and once we go crashed, yeah, so apparently OBS just crashed. So I'll give you guys about 30 seconds a minute to reconnect. Sorry about that. Can't really do anything about the streaming software crashing. So 30 seconds to reconnect for you guys. Sorry about that. Alright, so hopefully you guys are able to see this again. Again, I apologize for the stream software for crashing. So now we can move on, and we want to write this part into here. So we want to update ball location, and we also want to update it with collisions on top and bottom, and with collision on left and right. So we've kind of finalized that structure now, and we finally have our end of this, and this is going to be update scores. Update scores is essentially our scoreboard. When someone scores, obviously we need that score to update. Now, naturally, it should be included within this collision of the left and right, so we can go ahead and do that. So we want to say update scoreboard, just like that. Finally, we have our actual input outputs handling. So we have our key down and key up methods. What these do is they track what is supposed to be happening when each of these actions occurs. Well, key down, we understand when a key is pressed, something has to happen. Say we press the up arrow or down arrow. The computer has to recognize that. So these are actually perfect the way they are. They recognize it and they change the paddle in the direction that it should be. Right? It should be going, rather. Now, the more peculiar one is going to be the key up function, right? Well, key up, nothing should be happening, right? Well, yes, nothing should be happening. However, the way the key down function works is essentially the velocity is tracked as a number that determines the speed of the paddle. So every single time this updates, what's happening is the paddle is moving at whatever velocity this variable, paddle2vel, is stored at, right? So when we go ahead and we press key down, what happens is it stores a value as 8, but it stays at 8, right? Until key up occurs. It will continue staying at 8. And once key up happens, it will then reset both velocities to 0, so the paddle will stop moving. So, hope you guys understand what's happening in that facet. So now we can go ahead and we want to write in key down to track keys pressed, and key up to reset velocities. Finally, this is our actual game loop. the one that is called, so we can just go ahead and write game loop. You may be wondering why I went over this last part so quickly. It's because it's fairly standardized, and once you do enough programming, you'll understand that you'll find this wherever you program, basically, because it's just standard, really. So I will go ahead and I will show you guys the final pseudocode. Take a moment to look at this. So this really wants to reformat the file. I suppose it can go like that. Instead, we can just do our thing by doing that. So I'll give you guys about a minute to look over this. All right. So I will give you guys a minute, and if you have any questions, feel free to ask them in this time. Alright, so hopefully you guys get what's going on now, and now we can actually go ahead and start with our programming. So we've written these comments, there's no reason to remove them, so we'll keep them, right? The first thing we want to do is we want to write all our definitions down, right? No matter what type of program it is, we want to write our definitions down. So when we go ahead and write the definitions, obviously we can just go ahead, we can use this as a reference. And even for now, actually, we can just completely copy this part over here. And the reason for this is because we are basing it off of this, and there is no reason to not use the definitions that they've used as well. Now, remember to actually import this as well, the Pygame and the sys. It is extremely important that you go ahead and do this, because if you don't, then you'll get a bunch of errors and it will not be very fun. So we have all these definitions down, so that means that we can keep all our definition names the same. We go ahead and we move down a little bit. So we need to remember that the defining functions are going to be the most important functions, right? Not only these parts over here. So when we go ahead and we want to define the variables for our ball object, what we can do is we can just look at this, right? This is going to be defining ball init, and it's going to have a singular parameter. The parameter name that they use here is called write. So we will go ahead and just use write. Just keep it consistent where you can, right? And we can notice, alright, there's nothing we really want to do about this. We don't want to change anything in here, because so far, up to this point, we agree with the way that they wrote it. Same thing for this second function, init, right here. All it's doing is just defining our variables, right? Yet again, nothing too complicated. Now, the draw function is where it gets a little bit dicey, right? This is where we no longer agree with what is going on here. Because when we go ahead and we define our draw function here, what's happening is, I believe there is a parameter. Yes, we do need our canvas, obviously. It seemed a little convoluted to us, so this is where our changes are going to occur. For this first part, we don't want to change it at all, because it is simply drawing out our canvas for us. Nothing wrong with that. We do want to keep this part. Now, as soon as we get to here, where we want to update our paddle's vertical positions, this is where we don't like what is going on. Now, what we can do instead is we can actually just copy this part over here. And once we copy this, we can go ahead and paste that in a new method. We will just call that movement for now. So we will paste this in a new method. So we have to notice that what's happening is this is actually calling the paddles. We don't want that to happen. Instead, we're not going to number it at all. You may be wondering, well, paddle position doesn't exist, right? It says unresolved reference because it's simply not there. Well, why is it not there? It's because we haven't yet defined it yet. So we will get to that momentarily. Okay, so what we want to do is just go ahead and define paddle pos inside our parameter. And the second thing we need is paddle velocity. And inside the draw function, what we can do is we can just call movement and paddle 1 pos and paddle 1 velocity, just like that. And suddenly we can just do this with this one as well. We can do this with paddle 2 position and paddle 2 velocity. It's not quite done yet because we do need to define these back into here, but that is the a rough outline of what exactly we're trying to do. Now, we can actually go ahead and define this as paddle movement because we will not be entering our balls into here, because what's happening is we are going to notice something. If we go ahead and do this, there's actually only one ball and there are 2 paddles. So if we are to include all movement, all we're doing is essentially running the ball update twice as fast as we need to, right? It's updating 2 times back to back, and there's nothing in between here that would possibly change what in the world is going on. So now that we've determined that, we can now go on. All right. So we've called these 2 functions, and we look back here. Let's move that down to the comments. All right. So now that we go through this, we see, all right, update paddle location. Well, I no longer agree with what that is doing, right? Instead, I want to create a new function here. And this new function is going to be called defining ball movement. Just like that. Right? We don't have parameters yet because we haven't written what's inside it yet, but we do know something that is quite important. We still do need to call it within our draw function because it still does indeed need the location of the ball. So it says there's an error here. Oh, there's nothing inside this function at the moment. All right. So we can notice, all right, we're done with this part. Everything here is done already. Next thing we need to do is we want to go ahead and put that in there. Now, having these global variables is extremely, extremely helpful. Why is it helpful? Well, simply put, we can access the variables anywhere within this program. Normally, variables can only be accessed within, say, a class, within a method. And that makes it harder to traverse different functions, as you need to keep track of all of the variables, and it can get quite messy. So the advantage of having this sort of these global variables is you can access them from anywhere, and especially when there's only one ball, it's fairly easy to keep track of it, right? So we update the ball movement, and we can look, all right, now we want to go ahead and update it with the collisions on the top and bottom as well as the left and right. So we come over here and we look at this. All right, so this is actually going to be drawing the paddles on the ball. This needs to go, this needs to go into our draw function because it is part of the drawing, right? Next thing that needs to happen is we need to check the ball collision, and that is going to be right over here. All of this is going to have to be checked within our ball movement function. So now that we've gone ahead, we've pasted that in, we do need to call it in this. So how do we call it? All we need to do is just call ball movement, just like that. Nothing else needed. There's only one ball, so for now we can just keep it like that. However, there is something that we may be able to simplify later on, and that is right here. We notice that pretty much everything inside here is the same except for our left score and our right score. There's obviously some small differences here, like ball radius plus pad width plus ball radius minus pad width as the two different formulas. But we can see if we can switch that up in a second. If perhaps we can do that next week, maybe when we want to simplify the code a little more. So we go over here and we get to our final method where we want to put down our scoreboard. So our scoreboard can actually just be put into this method over here, or it can be put into our ball movement method here. Either one will work. We said ball movement method, although I'm not quite liking that. Instead, I want to put it into our draw function. So that is where I will put it for now. So we can go ahead and update the pseudocode. We also want to put update the scoreboard. So with this, now our scoreboard is updated. And we also want our key down handler, obviously. So we can just go ahead, copy and paste the code in. Remember, this code we completely agree with. And as a result, there's no reason to, edit the code. For now, at least. And finally, our game loop. The game loop is pretty self-explanatory as to what happens here. So this is going to be our first version of our shortened version of the code. So we can go ahead, we can look at the lengths of our different codes. So for now, this code is a bit longer because we have these comments here that our other program does not have, and a bunch of extra spaces. But we will see as we start entering in, classes and objects, as we start entering in other ways to shorten our code, that this piece of code will shorten down into a much smaller bit of code than before. So that will wrap up our lesson for today. If you have any questions, feel free to ask them right now. If you do not, I will see you guys next week, and we will be able to continue our lesson on functions, and we will finally start implementing classes into this. And once we implement classes, things will get a lot more fun. We can start putting 4 paddles, we can put 10 balls, we can do whatever we want, because that's the power of classes. So if you have any questions, ask them right now. If you don't, see you next week, and thank you for watching. Alright, so I see 2 questions. So Lion Gamer, yes, the code will be sent out via email later this week. I will try to get it out today. And Alan Zhu, I see you asked my friends who helped me before. So this is actually obviously going to be a something that we planned on holding long term, and having I guess an online meeting within this kind of class in order to try and accommodate our friends within this. It was very hard to do. There's many different layers that we had to go through, and we in the end just decided that it was quite inefficient, and So instead, I am the only teacher at the moment for this class. If we do plan on, I guess, extending the course or growing it in some way or another, we could have them come back, obviously. But, it's the situation of COVID, and there's no really easy way for them to be able to log on and effectively be able to teach without, technical complications. So hopefully that answers both of your questions. All right, sounds good. Thank you, and I'll see you guys next week.